Namaskar, my dear friends. Let us talk about S32K microcontrollers. So we will be seeing S32K 118 series microcontroller of 48 pin device. Okay, and this is the block diagram that we are going to discuss. We have a complete circuit design like we have power supply management and connectors. We have ambient sensors. We have temperature sensors like NTCs. We have humidity sensor. We have for automotive utilization like CAN transceiver, LIN transceiver. Similar to that, we have inbuilt ADC of microcontroller for some utilization. Then we have microcontroller reset pin as well as we have audio buzzer. Basically, this can be utilized for your alarm applications and all. Then we have separate analog temperature sensors and all. However, we have like EEPROM. Basically, I have implemented only with I2C right now. Then we have already put this CAN and LIN transceivers. That's fine. Then we have dip switches. Then we have push buttons for like user interfaces and all. We have LEDs. We have programming connector. We have discarded this IO expander. We have not put. Then we have ADC with SPI. We have UART USB bridge as well, and then a very high end DAC output is there. Okay, so we'll be having 4 DAC outputs, very high end. So however, we will start discussing the microcontroller circuits and their peripherals, how it has been designed. Okay, however, before proceeding to this, what we will do is we'll just try to briefly understand what is this microcontroller and what are the features and what are the applications that it can be utilized into. Okay, so let us start. So as you can see, this particular microcontroller is from NXP. So NXP is one of the leading microcontroller manufacturer in the world. And we have a exact part number which is mentioned here. That is FS32K118LAT0MLFT. Okay, so this is 48 pin device. As you can see from the website page of the NXP, I have put the like this is the particular circuit that you will see. This is the particular page that you will be seeing, right? Coming back to the features and like all the operating features that is there. So in one shot it is given that it has one core, it has M0 plus ARM Cortex, we have 48 pin, then we have 256 kilobytes of flash. Okay, we have 25 KB SRAM, then we have 2 KB EEPROM as well. So it has inbuilt EEPROM. Okay, then we have serial communications like I2C, SPI and UART. Then we have total 43 GPIOs. So out of 48 pins, we have 43 GPIOs available. Okay, we have CAN, we have CAN FD, both are there. If you have like HMI, so we have flexible input output. So basically this can be used for your HMI interfaces and all. We have security module like CACCs. Then we have 2 timers, we have PWM, and then we have 12 bit of ADCs with 16 channels total. Then we have one DAC as well. Inbuilt DAC is there, however we are not using for our application. Then this is a very important part, which is the power supply range. Okay, so the power supply range is there from 2.7 to 5.5 volt. It means this can be used for 3.3 volt as well as 5 volt applications. Then this has ambient temperature of -40 to 125 degrees centigrade, and it has AEC qualification as well. Okay, now what are the applications that this particular series of microcontrollers can be used into? So as we can see, we have lot of automotive applications. Basically, let's say active suspension. Then we have advanced exterior lighting. So lighting is very important in automotive these days. We have automotive zone controller. Then we have battery management as well. Okay, so battery management. However, we have like parking and stability control. We have diesel engine management. We have digital cluster. We have electric pumps, and several more applications are there. Okay, coming back to some industrial applications, we have automotive gas meters, avionics, building safety. We have heater meters. We have motor drives as well. So basically, lot of like motor drive application, it can be utilized very easily. Then we have smart lighting. We have power grid converters. Then we have water meter, as well as in home appliances. If you want, you can utilize it in home security and surveillances. Then major home appliances, basically fridge, washing machines, and all those stuffs, you can utilize it, even mixture and all. Then a small and medium appliances you can utilize. So this was all about like applications and the understanding of this particular microcontroller. However, we will get into the schematic design, how we are going to do the schematic design and what are the things that can be involved. And about this microcontroller we can take up in our another sessions. All right. So let me open the circuit. So this is the circuit. Before proceeding to the circuit, one more thing I would like to tell you. So this is the main page of the microcontroller that you will see. So if you copy and paste this particular part number into the website, on the NXP website, you will be able to see complete idea of this particular microcontroller. Okay. Like what is the pricing and everything, and then what is the operating features and environmental and everything. If you want to know complete information about S32K1, then you can go into that, and this page will be shown, which I showed you in my PPT. And this is the complete family tree. So we have 116, 118 and all those other series parts, right? So similar to that, every other things are there. This is the major applications that is there, that I just now showed you. And if you want to see the like its application circuit or something like that, you can click on this particular uh, link, and you will be able to get it. So what I will do is, in the description box I will give you the I mean uh, link for this part as well as for this part. Both the pages I will give you the links. Okay. Good. And this is the complete, like a part numbers that is available. So if you want to filter out, you can filter out with 118, and you will see the number of, like exact part number that is available with you. Good. So now we are ready to get into the circuit design. So let's start. So what is happening here is, we have the microcontroller nicely arranged into, like properly port by port. Okay. So we have PH0 to PH13. Okay. So I have first pin as, like trigger mux. It is just used as a test point, so it can be used for triggering some other external circuit or something like that. One PWM signal has been used as to drive the buzzer, and then we have I2C pins. We have like reset pin. Then we have ADC for potentiometer. Then we have